This is the charging port, and it does seem to be intact in and out. All the pins are attached pretty good and have a good connection. So at this point we're gonna have to start diagnosing the board. And first we're gonna look for any obvious signs of corrosion or any black spots, any holes, anything that looks suspicious. And as you can see, the board is nice and clean. This is of course the thermal paste. Alright, the other side, same thing here. So visual inspection, all passes good. Now this is one of the common chips that go bad, that P13 USB chip. So at this point we're gonna start by testing for shorts. Usually we might have some shorts around, so one pin to ground, the other pin we're gonna start testing the caps. This one is fine. Alright, no shorts any of these fuses. Alrighty, as you can see here, none of these fuses is shorted. Here we got no shorts, no shorts, and we're gonna keep going. Same here, this cap isn't shorted, it's one side to ground, the other side is not shorted. We can check these filters. None of them is shorted. Continuity. All good. Next thing I'm gonna check is by the USB-C, the charging IC, which is this one. This is also known to go bad. So we're gonna check continuity. No short, no short, no short, no short. And there is a short here. Yep. As you can see here, that's definitely a short. This side goes to the chip, and it is shorted. This is not supposed to be ground. This is probably ground, and this as well is shorted. So I'm pretty much sure these are on the same line. Most commonly, a cause is going to be the bad USB-C charging IC. Best way to find out is to take this out, and we'll see. If the short is gone, then that's the problem. If the short is not gone, then you can continue diagnosing. But I'm pretty sure once we take this out, the short will be gone. So let's see whether I'm right or wrong. And this is the M92 chip. As you can see, M92 T3. And there you go. Chip is out. Cool it down a bit. There's the heat sink. And now we could test for whether we still have a short on these two caps on top. So let's start with it. And no more short. So this pin is no longer shorted. Ground. Not shorted, and ground. Okay, so as we thought, it's the short is gone. So we're just gonna have to replace this USB-C, and this switch should come back to life. Let's go ahead and tin these pads. And see how it goes. All right. Right into place. And just like so. Now of course we're gonna go around and make sure all the pins are properly soldered. Add some flux. Okay, let's make sure you can see this. There we go. Alright, just making sure all these are properly connected. Let's go on this side. There it is. Do some cleaning. Some more cleaning. Here. This is going to be good. Alright, and as see, this looks good. At this point, we could go ahead and put the board back in the Nintendo Switch, and I'll be right back for testing. Alright, so here we are back. The Switch is back together for testing, and we plug in this charger, and it does seem to be drawing amps, and here it is. Switch is coming on, and as you can see, it's charging. And of course the battery is dead, but the Switch is charging. It says, as you can see here, that message was saying charge the console because it's gonna go dead. And there it is, 2%, and the charging sign. I'm gonna give it a couple minutes and make sure it's charging. Okay, here we are, a couple minutes later. This is still charging, and as you can see, it's 7% and keeps on charging. So at this point, the Switch is all fixed. This was a successful repair. As you saw, the problem was the USB-C charging IC, this one here, that we replaced, and it worked good after this. The old one was shorted. This one was shorted to ground, and by replacing it, we saved this from being thrown away. I hope this video helped somebody out there, and if you like the video, don't forget to like and subscribe, and I will be doing more videos.